Hello everyone! Welcome back to the channel. My name is Teacher Samuel, and today we're going to take a look at a very exciting perimeter problem. Now, this kind of question is a very common question in the SASMO contest. So, without much further ado, let's take a look at the question. I'll read it out for you. The figure below is a rectilinear shape. What is the perimeter in centimeters of the figure? Now, I invite you to take a pause and look at the figure and think about how you would solve this question. Now, I imagine that some of you might be thinking, well, all we need to do is just add up all the lengths of all the sides. And if you thought this, well, congrats! Your logic is absolutely correct. But take a moment to think, do we have enough information for calculating the perimeter in this way? Unfortunately not, because we don't have information on the lengths of all the sides. But not to worry, I'll explain to you step by step how we can solve the perimeter of this figure. But first, a very simple and fun example. Let's take a look here. We have a character Bob, and Bob likes to go running. Let's say that he runs 300 meters upwards. The star is the original position, and then he runs upwards. How many meters downwards must he run to return to his original position at the star? So, what do you think? If you said 300 meters, then congrats! You'll be absolutely correct. Now, how would you know that it is 300 meters? Well, simple. It is simply the same as the length going upwards. That's right. In this example, we see that when a man goes from an original position up and then he wants to come back down, the length upwards is equal to the length downwards. Now, let's complicate this example a little bit more. So, let's say on another day, Bob decides to run upwards 150 meters and then in the right direction for 50 meters. In which directions and for how many meters must he run to return to his original position if he cannot run the same route back and he must only run upwards, downwards, leftwards, or rightwards? So here Bob first runs up 150 meters and then to the right 50 meters. Now he has to return to the star. How can he do that if he cannot go back the same way? Well, first of all, which direction would he go? The only direction he can go is down. Now the question is, how many meters down must he travel? If you said 150 meters, then excellent, you would be correct. Now, how would you know it's 150 meters? The exact same way as in the previous example. The length downwards is the same as the length upwards. Now which direction must Bob go to go back to the star? Well, he would have to go left. And now the question is, how many meters does he have to travel left? It would be 50 meters. And how would you know that? It is the same as the length going rightwards. So in this example, we learned that the length going leftwards is the exact same as the length going rightwards. Just like the length going upwards is the same as the length going downwards. Now, take a look at this figure. What do you notice is peculiar about it? Well, if you look closely, you would realize that it is a closed figure, and it only has horizontal and vertical lines. In fact, it looks like a very familiar shape, like a rectangle, which is still a pretty simple shape, and we know how to calculate the perimeter of rectangles. Now let's see if our rules about the length of the sides left and right being equal and the lengths of the sides upwards and downwards being equal remain for a very complex figure like this. Well, you see here, we also have a star and original position. And in this figure, I've already marked all the directions for you. So for instance, at the star, first we go up, then right, then down, and so on and so forth. Now let's see. Can we use the same rules for a more complex figure like this? Well, we can calculate it using the figures. So, first we would look, how many sides are direction up? I see 2 sides, over here and over here. To calculate the total length going upwards, we would simply add both of these side lengths in red. So 6 plus 5 centimeters, which is equal to 11 centimeters. Now, how many sides going down? I see 2 as well, over here and over here. And if we add the 2 side lengths together, we get 11 centimeters. Now, what about the sides going left? Well, actually, there's only one, right over here in pink. And the length of this leftward direction is 10 centimeters. Lastly, let's take a look at all the sides going right. And we see 3, here, here, and here. And if we add up these side lengths, what do we get? 5 plus 3 plus 2, which is 10 centimeters. Now, take a look at the bottom of your screen. Do you notice anything about the lengths of all 4 directions? Well, it's the exact same as the examples. If we look at the length going upwards, it's the same as the length going downwards. And if we look at the length going leftwards, it's the same as the length going rightwards. So we see that even in this very, very complicated figure, we can use the same principles as the ones we saw in the simpler examples. And this is a great realization because we can then use these rules for our question. So let's take a look back at the original question. Here is the figure. Now, what do you think is the first step in this question now? Well, we would have to start by marking the directions because this figure doesn't have the directions already in the figure. So you can choose an original position. There are many you can choose from around the figure, but I'm just going to choose right over here, the star. And even with the star, you yourself can choose whether the character goes up or right first. I'm going to choose going to the right. And so I'm going to mark right as my first direction. And remember, we have to mark the directions across and around the entire figure. So we just follow after we choose the first direction. So if I choose right, then my character next has to go up, and then right, and then up, left, down, left, up, left, down, left, up, left, down, left, up, left, down, left, up, left, and for the last side, down. And finally, we're back. Phew, that was a long road, but we're finally at the end. Let's see, what do we do next? Well, we would have to calculate all the lengths of all 4 directions. So let's see if we can do that and if we have enough information. Well, we start back at the original star and we go along the path to C. The first side is direction right. Do we have information on this particular side length? It seems like we don't, but it's okay. Let's keep going and see. Next we go up. Also no information. No worries. We go right and think about it. Do we have information about this side length? Maybe not this particular side length, but what other information do you see around here? Take a look at the figure. We take a look at these 2 sides, both going in the right direction, and notice we have information about the total length of these 2 sides. It is 52 centimeters. And if you take a closer look, you'll see that in the whole figure, there are only these 2 sides going right direction. And so we know the total length of direction going right in this figure is 52 centimeters. Very good. Let's keep going along in this figure. So next we go up, and again, we don't have enough information, but that's fine. Let's continue. Left, no information. Down. Do we have information here? Yes, we do. It's 6 centimeters and it's the direction going down. But let's keep going because there are more sides that are direction going down. We go left, no information there. Up, no information. Left, also no information. We go down and we see information here. This length going down is 10 centimeters, so we add 10 to the length going down. Let's keep going in the figure. We go left, up, left, still no information so far. And then we go down, and we have 4 centimeters for the direction going down, which we add. Let's keep going. Left, no information. Up, no information. Left, no information. And down, 12 centimeters. Very good. And so we add 12, and we keep going left, no information. Up, no information. Left, no information. The last side is down, and we have information also for this side. It is 22 centimeters. Now, let's take a look. How many sides are there going down? Well, there's a total of 5 sides. And look, we have the lengths of all 5 sides. So all we have to do is add the lengths together for the downward direction, which adds up to 54 centimeters. Let's see. Do we have enough information here to solve this perimeter? What do you think? Well, if you're paying close attention to the previous examples, you would know the length direction upwards is the same as the length direction downwards. So the direction length going up, total length is 54 centimeters. And what about the total length of the direction going left? Well, it would be equal to the length going right, which is 52 centimeters. Now, with this information, how would you calculate the perimeter? Well, it's simple. We would take 54 plus 54 plus 52 plus 52 to get a perimeter of 212 centimeters. And it looks like we have solved this problem. Now, let's summarize everything we've learned so far today. So, in today's video, what we've learned is that we have perimeter questions. And these perimeter questions can involve closed figures with only horizontal and vertical lines. And with these kinds of perimeters, what do we do to solve the question? Well, first, what we need to do is we need to draw those arrows, remember? And we call that marking direction. And after we mark direction from the original point all the way back to the original point, covering every single side, all we need to do is add up the lengths of all 4 directions, remembering that the length upwards is the same as the length downwards, and the length leftwards is the same as the length rightwards. And that's how you can solve questions of perimeters of closed figures with horizontal and vertical sides only. Now that we've gone through this question, here's a practice question. Take a pause at the video and see if you can solve it on your own. Don't forget to put your answer in the comments. Lastly, feel free to contact me by scanning the QR code on the left if you have any questions, or you can scan the QR code on the right to join our study group. Thank you for joining me today.